Hello class, and welcome to talk number 3. We're going to continue with the Cascade circuit. In the last video we looked at the Cascade circuit using 2 cylinders. This one's going to use 3 cylinders, which is rather similar but is more in line with your design. I've put a fairly simplistic sequence which doesn't cause too many problems, but it is a random sequence, so it's not one that you can actually use. If we follow it through, it goes C plus, A plus, B plus, and then C minus, B minus retraction, A minus. But if we think about it more carefully, we have to undertake really the thoughts of where the trap signals are. So if we imagine this, we're going C plus, A plus, B plus, and of course when it goes to C minus, it can't do the C minus because the pluses are already in position. So we know we have a trap signal at that point. But we'll continue from there and we'll say C goes C minus, B goes B minus, A goes A minus, well, at the last stage. But of course now that C wants to go C plus, it can't because we're still on the minuses. So we have the second trap signal. So we've broken the sequence into 2 particular areas. Group 1A for the plus operations and group 2A for the negative operations. Now that we know that, we can actually pipe the circuit up and we can make what would be a usable operational circuit. So let's do this. We're starting from G1, so we're going to start from the G1A, and we can see the G1A is already coming through this cascade valve. But we want some control of this, and so we're going to have the push button to initiate the first stage. So here's the push button, a 3-port, 2-position, button operated sprung return valve. So G1 is now going to start C+. So I'll take G1A and I'll feed it into the push button. When you press the push button, air will go through, and again imagine this top section comes down and this diagonal arrow replaces this stage, and therefore the air goes through, it goes out, and the first stage now is C goes into its positive forward stroke. So this has been achieved. It hits the valve on the outward stroke, the final position. So this must be G1A, because G1A is the air we're presently using. This signal is going to be taken and it's going to feed all of the way back, and it's going to operate A+. So A+ now goes forward. A goes forward and hits this signal valve on its forward stroke, which is also on G1A. So all the G1s are fed to this manifold. It hits the valve, and this valve then operates B, so B goes forward also. So B has now gone forward, and we've got all these 3 operations within group 1A. As this goes forward, this must also be on G1. It's taken the final signal of the B positive stroke, but we have the trap signal. So it has to eliminate the trap signal by eliminating its own grouping. So it takes the air from here and it feeds the air down, 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 up, and to that side of the valve. So this valve goes across, and the air from this main supply is now going to go through here and out of G2. Therefore, all G1 has been sent to atmosphere, including what was the trap signal. We've now brought on G2A. So G2A can continue with this sequence. Its first operation is C minus. So what we're going to have is C G2A is going to go through and operate the valve, the directional control valve, for C to go C minus. I'll just tick this one. This must be on G2A because G2A is now fed and it's now on for the first time. C has gone negative. It takes the air and it feeds the air through, down, and sends B to B negative. This one has now been achieved as well. B goes negative, it takes the signal on retraction. Consequently, this must be on G2 here as well. It takes the G2 air and now needs to do the final operation, which is A minus. So it sends its signal down, and we're going to take it across here for convenience only. I'm going to take it across here to here, and it's now going onto this directional control valve and sending A to A minus. The whole sequence has now been completed. This must be on G2 air. But it has the trap signal to eliminate. It wants to return to the push button stage. So the G2 air, which comes from this valve, is going to be the one that re-establishes that position on the Cascade valve to send G2 to atmosphere, bring on G1, and G1, its first stage now, is to power the push button to continue with the sequence if necessary. This can be in any particular order, and if it's got two groups, then you would fulfill it in a similar method. On a later video, I will show you how to overcome problems where there are maybe 3 trap signals, and it's more complex, and I'll show you how to do that in a later video. Little add-ons to this, little things you need to remember. If you want to delay with a timer an operation, so let's say you want to delay A+, it's easily achieved. You simply fit a flow control valve, and I'll put in the required check valve. It allows the air to come back when required. It's going to control the flow of the air to the operation of A+, but it needs to delay, and so yet again we're going to put on there a receiver, and that receiver will take the restricted air, it will build up the pressure over a set volume, over a set time period, and then it will apply the signal. And dependent upon the volume here and the restriction here, we can adjust this to get whatever we want. And for this example, I'm going to say maybe 20 seconds delay. One last feature would be if you wanted to slow down the operations of the cylinder. So again, if you wanted to slow the operation, if we wanted C cylinder to come back slowly, we could use a flow control again. So this is in the metering out. This is where the air comes out of the cylinder. It's sending the air out to atmosphere, and I'm going to put in a flow control valve. I'll face the check valve the correct way, and now as the air comes out through here, out of the valve, to go backwards, it's going to put the check valve onto its seat, it's going to restrict the flow, and the flow will come out and it will slow the retracted stroke of that particular cylinder, if necessary. This is how you can achieve your sequential circuits that have 2 trap signals. And I know that the one that you're designing has got 3 cylinders, so you need to follow this method. Now the next video will be related to hydraulics. I'm going to look at the regenerative circuit and how to implement regenerative circuits and normal operation circuits together. But at this stage, thank you for watching. Goodbye.